All right, let's understand something. First of all, there are animals where the male will mate with the female and she'll never see him again, just like with some humans. And then there are others that will mate with many females, okay? As with some humans. And then there are some that will mate once for a lifetime, and if their mate dies, they will never mate again. All females care for their young, except among some humans.
That's not true.
Now, with the penguin, you know, well, I'm saying all females, they care about their young, okay? With the penguin, the male takes care of the young. But somebody is taking care of the young, but at the same time, while the male penguin's taking care of the young, what is the female doing?
She's out working.
She's getting food. You have a family situation, all right? So what I'm saying is this family relationship we see among some animals where they mate, and that's their permanent family. They protect their family, they care for their family. You know, don't be coming into, for instance, let's take the gorilla, where the male gorilla is the protector of the family. Don't come into his territory where his young are, because you're going to wind up with a very, very upset gorilla. Okay? If you look at grizzlies, the female is far more defensive than the male, and she will protect the young. So you do have that family rhythm. The question is why? Biology will not account for relationship, emotional relationship or psychological relationship. That's what I'm talking about when I say that you can't use evolution to establish familiar relationships. We see them, you know, they exist. We can't explain them. There's a certain survival benefit to it with some animals, but then again, you might take a look at the animals that eat their young before they escape and say, well, that's for population control. I mean, no, we can always come up with an excuse for something. As a survival trait, yes, I agree it's a survival trait, but the question is why? This is not a biological thing, this is a psychological, emotional thing. And that's the thing that I simply said that, you know, evolution can't account for. Attitude. Right?
Okay, where to start with that? There are a variety of mating and parenting strategies throughout the animal kingdom. You talked about a few. There are also other strategies wherein the females will mate, lay the eggs, and then just abandon the males and the babies. There are some where both the parents abandon the species, obviously. But every one of these strategies has been come upon because it's the most advantageous strategy for that species. It's the one that allows both parents to basically to produce the most offspring and grandchildren and great-grandchildren. And that's the way that evolution is selected for these things. To say that it has to be an emotional connection is very difficult to justify when you look at insects that care for their young. And just to assume that familial relations, that those sort of connections are emotional and can be found in insects is quite an idea, quite a statement. I'd like to hear a little more.
To add a little bit to the topic that we're talking about right now, the interaction between males and females in different species and how they interact in the process of mating and rearing young is, I think, one of, if not the most interesting subject within evolution. And it's a good example of how we can look at a whole bunch of different behaviors and we can go, how could evolution by natural selection possibly produce this type of behavior? How can it possibly produce this type of behavior over here? And it's a good opportunity to step back and kind of look at what happens to the notion of evolution by natural selection once we change our view about it. All of these objections that we have, where we say, I don't see how it could explain this. this is another obstacle, this over here. All of these things that stop us from accepting evolution as a process that's actually happening. Once we step across the barrier and say, you know what, I may not understand all these things, but it's clear from the evidence as a whole that evolution by natural selection has happened. Once we step over that bridge, something kind of magical happens to all these little subjects. Instead of being barriers to understanding, and instead of being annoyances and things that irritate us and go, that doesn't make any sense, what happens is they become kind of magical little mysteries where we say, how could it do this? And instead of saying it with a negative tone of like, how can it do that? And get rid of it. What we do is we say, how could it possibly have done that? And then we look into it and we study it and we go into it, and that's what biologists today are doing with massive amounts of fervor and interest, are looking at all of these questions and saying, we know it's happened. From all the different lines of evidence, we know that we're all related through common ancestry. How could it have done these things? And the answers to questions like these, the ones that the answers we have, are fascinating and wonderful and interesting, in my opinion.
Okay, to the creation side, I'm sure you've heard this question before, but I'll ask it anyway. With the 7,500-year-old Earth, how is extinction explained? And related to that, why weren't the dinosaurs put on the ark in accordance with the biblical account for all animals being put on the ark?
Well, first of all, who says dinosaurs weren't put on the ark? That's an assumption, number one. Second of all, the answer to your question really is, if we accept the fact that catastrophism as opposed to numerous catastrophes, one global flood, that would explain the massive sedimentary layers around the whole Earth. 75 to 80% of the Earth is covered by sedimentary rock, which is rock that's been overlaid by water at some point in time. We have seashells on top of all the mountains. We have unconformities with the, in example, you see cases where the rock is folded and bent, but it's not cracked, which indicates a time where it was obviously soft mud and it just became hard after the flood. I think the flood, if we accept the flood as a historical fact, then it explains the fossil graveyard, it explains extinctions, it explains the stratified layers, and so it really does fit the model. So the question what it comes down to is, does the global flood, is there a scientific basis for it? I think there's a lot of good arguments for it.
If you take a look, for instance, at the number and the size of coal seams and oil fields, we know that all of this is created by biological material that is degraded. Carbon-14 is found in all oil samples. It is found in all coal seams. Also found in, well, diamonds, yes. Which tells us by half-lives that coal and oil has to be 60,000 years or less. Now, when you look at polystrata trees, where you've got trees going through multiple strata layers, and some of those trees are upside down, you know that this was not formed by those trees growing there, because trees do not grow upside down. So all of this stuff is brought and buried together to become oil. Now, when you look at the oil, there's some interesting things too. You've got hydrogen and you've got methane. Methane is a gas that forms from biological disintegration. Coal mines are full of methane. Why is it still there if we're looking at millions of years? These things trapped in the earth. Methane and especially helium, you'll find in zircon at the Cambrian level, and zirconium crystals at the Cambrian level. That should not be there if the earth is millions of years old. We even have a case of hemoglobin being found in dinosaur bones. I'm sorry, hemoglobin will not last for millions of years. It degrades, it breaks down. Biologically, that's impossible if